Okay, here is Jasmine with ThatITShow once again. Since I have nothing else better to do, I decided to try my hand in installing different environments and to test my skills and see what I forgot about different things. So today I'm going to be dabbling in OpenStack. Now, OpenStack is a strange beast. If you ask anybody, you are going to get different answers. Either they're going to go with you shouldn't install OpenStack on your own hardware at all. You should be concentrating on using something else like OpenStack in the cloud, or you should be also using commercial OpenStack installations. Or the other people are going to say you should always try to install your OpenStack installation clusters and so on, so that you actually know what you are dealing with. OpenStack is a complicated thing, and when it comes to the entire system infrastructure and the entire infrastructure of how the system actually works, it's pretty hard to explain all the nuances and all the details when it comes to OpenStack as such. And I'm just going to go with the barest of the bare guides or comments on how the OpenStack itself actually looks like. What are different things that you should know about OpenStack, and the reason why, and the things that you should know about how the OpenStack actually works. Now, the thing is, OpenStack itself is basically a set of services, and its main intention is to create an architecture that is going to enable you to run virtual machines and basically almost every other load available. So the idea of OpenStack is not creating a single thing that can do a single thing. The idea is to create an architecture that enables you to scale both horizontally and vertically, and also to run different loads under different conditions, and to try to unify everything that you have at your disposal. So all the networking, all the storage, all the computing, and all the other equipment that you have. Now, the idea of this thing is pretty complicated when you come to think about it, because it is trying to do a lot of things at the same time. So I'm going to go with a couple of images before I start installing OpenStack and try to explain what we are doing here. So we are these guys up here. We are the users. And what we do is we are able to communicate with OpenStack, so the entirety of the architecture, through different means. Now, we can either use the interface called Horizon, and this is going to be driven via HTTPS or HTTP through a browser. So this enables you to actually connect to something and have a graphical user interface to control the entirety of the OpenStack. You can directly control the compute part. You can directly control the object store part. You can directly control the block storage part, or you can directly control the networking API part. Everything is controlled through an API, so programming calls. And this can be done using keys, using different ways of identifying yourself and so on. And this is handled by the OpenStack Identity Service. So basically, if you are using either Horizon or you're using any kind of identity, any kind of API, you are going to get yourself identified by either a token or any other service that enables identification. And then you are going to be able to use different means to control and to connect to different things. So as a user, usually you're going to use the horizon to control everything. As a scripting user or as an orchestration user, you would probably go and use APIs and specialized tools that OpenStack offers to people, so that people actually can operate more easily. Ansible has dedicated modules for it. Puppet has dedicated modules for it. Basically, every orchestration system has dedicated modules to be able to communicate with OpenStack. And also, OpenStack is not only these services, but a bunch of other services. So when you are dealing with things that you can see here, this is just one piece of the puzzle, because the puzzle itself is huge. Now, the thing that we need to understand here is that when it comes to architecture, design, and everything else, there are different services that provide different kinds of support or different kinds of resources for OpenStack Cloud. So there is not a single block storage system. There is not a single object storage system. There is not a single image service. There are a couple of services that do different things. Also, the compute part can also connect to different APIs to not only use KVM. We can also use different other vendors and different other solutions for virtualization. It can connect to different other kinds of block storage. It can connect to different other kinds of object storage, for example, S3 buckets and so on. So the thing is that when it comes to different things that you're going to be seeing and using while using the OpenStack, heavily depend on how do you want to install your architecture. Now, this is the biggest problem that we are going to be facing today, because what I'm going to do is I want to give a quick, short and dirty introduction to OpenStack. When you see an image like this, you are going to be I'm not going to say alarmed, but you are going to say, okay, this may be too complicated for me. Once you understand that you can also choose different hypervisors, choose different storages, choose different networking configurations, that you can connect networking hardware outside of the virtual hardware that you're going to be using, and so on, then you're going to understand that this can be a huge problem, and this can be something that is complicated to understand and complicated to install, at least first. So, for example, if you are dealing with hypervisors, the OpenStack says that they are supporting LXC and KVM, which is expected, QEMU, which is expected. Then they are supporting Zen, they are supporting Zen server, Hyper-V, UML, Virtuoso, PowerVM, VMware SXI, and VMware as such, Ironic, which by itself is not a hypervisor, it's a different thing. So OpenStack is more or less trying to be able to connect to everything that is on the market to enable one seamless experience. I'm going to go with what they're saying in the documentation, and they say that OpenStack supports many hypervisors to various degrees, and this is probably the closest to the truth. Although they say that they are supporting everything, the experience is going to vary. So you cannot just expect that you're going to be installing one OpenStack node and then connect to whatever you have in your organization and say, okay, this node is going to be one ruler to rule them all, because it won't. It's going to be much more complicated than this. But if you are implementing something in a complicated environment, OpenStack can probably do that, usually with a lot of technical tweaking and with a lot of technical knowledge required. Nevertheless, I think that OpenStack is one of those things that you actually need to try and you need to take a look at. And I think that the most important part is that you actually need to try. You actually need to install OpenStack and you need to try to tweak with different parts of it. And then after you have finished understanding the most important parts, so for example, horizon, storages, computing, networking, and identity, then you can slowly build your knowledge and try to include other types of storage, other types of hypervisors, other types of image services, and so on, backups, and every other service that is available. Because you are going to be, as soon as you go to the OpenStack site, you're going to understand that the software itself and the things that are components of the OpenStack are numerous. So, for example, here there are some things missing on this image. There is a better image, and I'm going to try to find it. Just give me a second. And the thing is that you basically want to, okay, this is the thing that I'm looking for. Just a second. Okay, so this is the OpenStack map that says, or that is trying to explain that you have different web frontends, you have different workload provisioning systems, you have different application lifecycle systems, orchestration systems that are built both inside and outside of the OpenStack itself. You have different compute services, one for virtual machines and one for containers. You have different types of storage. You have different types of networking. You have different types of hardware lifecycle services. You have shared services that are able to store the images, to do the identity, the scheduling, the secrets, and so on. Then you have tools, enablers that enable you to actually connect to other services outside of the OpenStack cloud. And you have operation tooling that enables you to actually integrate all of this into something that can be implemented in a large-scale architecture. So all of these names here are more or less different projects with their own documentation, their own specification, and they're all trying to be one single architecture. So don't be afraid, but expect that the documentation is going to be a little bit different. Expect that the things that are not going to be so straightforward, but as such, OpenStack is a great thing to have and great thing to actually try to run. Now, having said all that, there are basically two ways to install OpenStack. First, you need to understand that, as the saying goes, there are multiple ways to skin a cat. There are multiple ways to install OpenStack. Since the OpenStack project has been developing in different directions, while at the same time maintaining one unified release schedule and one unified face towards the users. So when you try to install OpenStack, you need to understand that either you are going to go and create your own cloud with nodes. Those nodes are going to be requiring different services depending on what the node is. Is it the storage node, the compute node, or management node, and so on and so on and so on. It's not important right now. Or you are going to go with cloud solution that is already half installed. So basically what you do is you finish the installing, and then you are done with the OpenStack, and then you go to the next step. And the next step is actually, after the installation of the architecture is done, to configure the thing, because the configuring the thing is not a simple thing, especially if you have a huge installation. And there are installations with millions of CPUs installed and hundreds of petabytes of memory out there that are using OpenStack. So there is a huge amount of knowledge and huge amount of things that are happening on this in this product. Also, one more thing is that you can, if you are unable to or don't want to create a huge installation, you can choose one of the smaller installations. And now, smaller installations are a strange beast in OpenStack. You're going to find out that there is a couple of them, and by couple I mean actually quite a few. So you're going to be seeing things like PackStack, DevStack, and so on and so on. Some of them are official, some of them are less official. All of them enable you to do some kind of automation. And the reason why this is important is because installing OpenStack is anything but easy. OpenStack relies on a huge amount of services. And there are basically two different approaches. One approach is to install all the nodes, install all the services, and then get all the services running on all the nodes and then integrate everything. Or install Docker, then install all the services as Dockers, and then integrate them between themselves, and then try to get the whole system running. When I was starting with the OpenStack, probably, I guess 7, 8, maybe 10 years ago, there was a running joke that there is no single OpenStack installation available, that it's just like a sourdough bread, that you have that there is a proverbial pra node, so the node that has been installed, and everything else is just basically a fork of it. Of course, it's not so, but it used to be that installation of OpenStack would take you the entirety of the day. Now, with Dockers, with different solutions like Puppet or Ansible and so on, you're going to see that it's pretty easy to install OpenStack. But bear in mind, OpenStack is not a simple architecture, and it's not, you cannot even call it a service or a solution. It's just a complete architecture covering everything, from end user, from identification, from virtual machine storage, everything that can be done in a huge, or basically any enterprise, basically. So you can run millions of users, you can run one user, and it is trying to do it all. Now, usually when I'm dealing with OpenStack, I either install PackStack or DevStack. PackStack was the one that I used to install because it was the one that was using CentOS, and it was intended as the simplest installation there is. Now I have decided, and this is one of the reasons why I'm doing this video, I have decided to do the DevStack and try to see how DevStack installation is working. So I wanted to see something new and something different. What I have here is a freshly installed clean installation of Ubuntu 24.04.2. So the latest version of the LTS Ubuntu server. And the reason why I'm using Ubuntu, and the reason why I'm using the clean installation, is because it is the recommended way on the in the official OpenStack documentation. So it says that DevStack is going to be a series of accessible scripts that is going to quickly bring up a complete OpenStack environment. This is what we want to do. It needs a clean and minimal install of all Linux system. They are attempting to support 2 latest LTS releases of Ubuntu, Rocky Linux, and OpenEuler. And if you do not have a preference, Ubuntu 24.04 Noble, the one that I'm using here, is probably the one that will probably go the smoothest. So I decided to simply go with the path of least resistance. I'm completely following the documentation. The documentation itself is, I'm going to put it here. So documentation is here, and you can take a look at it. So basically it's a dev stack, and I can just actually put it on the, I'm going to put my screen on the left and the documentation on the right, and just make it a little bit bigger here, so that we can actually follow the instructions and see what actually needs to be done. So what are the differences and so on. Okay, and now the minimal requirements. Depending on who you ask, the minimal requirements can be as little as 50 gigabytes of space, and that's it. I decided to go with 150 gigabytes of space. This is a virtual machine, and this machine can be extended. And I decided to create a small machine that is going to be just a test machine. And the idea of this is that this dev stack is mainly intended to create an environment for functional testing, and the environment that you can run on your laptop. So the intention of this is not to have heavy computing performance. The intention of this is to actually enable you to run all the OpenStack services and to see how they work. So I'm going to go with the simple plan of just simply going on and on and trying to do the things that need to be done to install the thing. Now, a few important things. My user ID is demo. My hostname is demostack without any domain. And I'm going to be going and quickly copy pasting things from here and trying to explain what I'm trying to do. So first and foremost, the OpenStack usually runs under its own non-root user, sorry. So it should be run as a non-administrative user that is able to log in and that is able to actually execute things, but it needs sudo to use the administration rights. This is a thing that can be circumvented. So you can actually install OpenStack as a root user, but since they are recommending that we are doing it as a regular user, we are going to go with okay, let's not go outside of what they're trying to do. Now, the next thing is that they say that we need to ensure that the home directory for the stack user has executable permissions for all. Let's see if that is true. I'm going to go and see what is happening to the opt stack. And I can already see that I don't have permissions to see. Let's see what is OpenStack. Okay, so we have executable permissions for we have executable permissions for the directory, but directory actually belongs to stack. So, and I'm logged in as a demo. So what I'm going to do, I'm just going to do this change mod, although it basically doesn't matter. So I have just given the other permission for the execution to the directory, and this actually probably gave me the permission to actually go into directory and see what the permission is. No, okay, anyways. Now the next thing is that the user that we have just created should be able to do the super user commands. So we are going to just echo the required line into the etc sudo as the stack. So we are basically creating a file called stack inside the directory that we are that contains all the sudoers, and this is probably the right and canonical way to do it. You could theoretically go into the sudoers file and directly put the user in it, but it's much easier to control the system if all the users and all the different groups that we're creating have their own separate sudoers D entry or the file. Now, I'm going to switch over to the user called stack into the interactive shell. So this should be working. Okay. Who am I? I'm stack. Where am I? In my directory. My directory is OpenStack. Okay, fine. Good. It works. Now let's go and download the devstack. Now, since I'm in the OpenStack directory anyways, this is going to be fine. So I need to do the git clone. Now, I probably don't have git. Oh, I do. I didn't remember installing it, but anyways, I do it. I do have it, so fine. I'm going to just clone the git from here. And I'm going to go and clone it here and clone it to devstack. This is going to be a pretty large download. 10 megabytes, not bad, because it is going to then download all the different things that we need. Let's go to devstack and see what we have here. Now, there is going to be a script here that's going to install everything that we need. What we are going to do is we need to create the file that is going to be presetting the passwords for everything that we are going to be doing in the OpenStack environment. Now, usually, and this would be a regular normal thing, all the different services that we are using, so the administration, the database, the Rabbit service, and the service password, would be completely different. This is fine because we are doing the configuration that actually makes sense for from the standpoint of a developer, because we don't care. But it's not wise to do it this way. Database password should be separate, Rabbit password should be separate, service password should be separate, and also in the normal regular installation of OpenStack, these would be on different nodes, or this would be on different clusters even. So database would be the clustered solution probably. It says here that there is a sample local conf file under the samples directory in the devstack repository. So if I go to samples, I can see that there is local conf. I'm going to copy my samples local.conf here. I'm going to just see what local.sh is. Sample for user tester and automatically successful conclusion of stack sh. If you wrote it work properly, but some of the things you find useful to run as a stack sh that the OpenStack configuration for devstack produces. Okay, so basically what they're doing here is they are leaning on the installation, and after the installation they are doing importing of the keys for the user. They are creating a new flavor, they're creating a protocol, they're just creating simple things that make your life easier to create something that is going to be a machine that is going to be useful if you want to just set up things. Okay, this is fine. I'm completely fine with this. So I'm just going to go with the this, and I'm going to as they say, copy this file to the root devstack directory for it to work properly. Okay, fine. So what I'm going to do, I'm going to copy the sh file here. Now I have the local conf here. I have the local sh. Fine. I'm going to see if the local conf has the things that are here. Okay. This is the collection of the settings, minimal contents. What I'm going to do is I'm going to do the same thing that it did. So I'm going to go with the same password for everything. Reason being, I'm completely lazy, and this shouldn't be done like this, but I want to make sure that I'm doing this thing as quickly as possible. They're auto-detected. Let's hope this thing works. I'm going to go with let's hope this thing works, because the thing is that I'm working on a host that is a virtual machine that has its own local IP and so on and so on. So let's hope that this is going to be auto-detected correctly. I don't see the reason why not. There is only a single network card, but let's say, okay, this is going to be something. Now, okay, there is also a warning that is interesting. Only use alphanumeric characters in your passwords. Some services will fail to work when using special characters. This is completely the opposite of always use different special characters in your passwords. But anyways, I'm not the one that usually uses the alphanumerics. I tend to use longer passwords because I believe in higher entropy. So I believe in the passwords being as long as possible. So some of my passwords are 64 characters or more. Okay, so this is it. Let's write it out. No, let's not do it like this. Let's do it like this. Let's save it. Okay, now let's start the install and see what is going to happen. Stack sh. Okay, this is going to be fun. We are just in it for the ride. As I said, it is going to download a huge number of things. It is going to download a huge amount of different packages. It is going to download a huge amount of different Dockers, and then it is going to create images, and then it is going to create running machines that are going to be services that are needed for different things. You can actually see what it is doing right now. So it is preparing the system to be able to get the networking, the Dockers and everything else rendered. And then, so basically this is getting the libraries prepared. And this is going to be a lengthy process, but from the perspective of something that needs to be done, this is not a complicated thing. It shouldn't fail, and I do hope that it's not going to fail. I'm going to just go and say that this is going to take a long time to finish. So while we are waiting for this thing to finish, I also wanted to find another image. And talk about different things that are part of the OpenStack and part of the idea of what OpenStack actually is. So let me just see the building blocks, and let me just see. I'm trying to find an image that I know exists, but I don't know the name of. Okay. So this is the what we have seen is the conceptual architecture. So the idea of what I showed you when I first showed you the image, the first image that I showed you was this one. So this image basically tells me or tries to explain the idea behind the OpenStack itself. So it tries to explain that there is a authentication system, that there is a horizon that provides user interface, and there's a ceilometer monitoring system that is enabled to, if you want to enable it, to monitor everything. You can use the VMs, or you are going to be providing the VMs, and since this is the architecture or the relationship architecture, so conceptual architecture, it deals with relationship between different services, shown as oblong basic oblong shapes, and this square shape that depicts the VM. So the idea is to try to explain how the VM relates to all the other services. So the neutron service is going to provide the network for the virtual machines. Ironic is going to provision virtual machines. Throw is going to provision, operate and manage virtual machines. Nova is going to provision and use everything else to create the virtual machines at its disposal. Glance gets the images, has the images, and it's used to provide the images for the virtual machines. Swift and Cinder are storage services that are either blocks or objects, and they are used to provide the storage and volumes to the VMs. Heat is used to orchestrate everything, so it is involving everything directly, Nova, Glance, Neutron, and so on. And it is giving explicit instructions or using explicit instructions to create not only different virtual machines, but also stacks of virtual machines and all environments inside the OpenStack. And then the idea is that these are the services that we are going to be using to accomplish these things. Now, when you're dealing with services, you're going to be seeing that there is a project navigator that gives you the information about different services here. So orchestration is not only heat, there is a few of those, workload provisioning is a few of those, and so on. Also, there is operation tooling, there is add-ons to services, there is integration enablers, and so on and so on. So this is the other diagram that I showed you. Now, the thing that I want to show you, and this is the mother of all the images, is the image that is the OpenStack architecture. So when you think about OpenStack, the logical image, the one that I have shown you here, so the idea of having a virtual machine in the center of everything, and then having services that are going to be dealing with the things, actually translates into this. This is the actual how the actual OpenStack and how the OpenStack works. Now we are these guys here. We use APIs or CLI agents or clients, sorry, or graphical user interface tools to operate all the different services. The dotted lines are the services themselves, so each box is a different service. And as you can see from here, you can see that almost every service has its own database, has its own servers, controllers, or whatever they're called, and it has its own way of queuing different parts of things that you are expecting from it. So the Nova, which is intended to do this computing, so operating the virtual machines, has the scheduler, has the queue, has the console, has the conductor, and so on. So different parts that are important to be able to talk to the hypervisor, and then to actually create an instance. You have the database that is able to store the information about what is actually happening. You have the Swift that is object server. You have the Glance that is the image service. You have the Ironic that is able to talk to the bare metal services. So this is intended to run the OpenStack and virtual machines directly on bare metal. You have the orchestration, and you have Keystone that is intended to do the identity. So you can see that it is a database, LDAP, and optional. So there are other different optional services. Usually the service behind this all is LDAP in one form or the other. Networking is done by Neutron, And the neutron is able to talk to a layer 2 and layer 3 equipment. So neutron is not only directly connected as a virtual service, it can also talk through plugins to different actual pieces of equipment. So you can theoretically integrate your existing equipment into your OpenStack environment. I haven't seen it done. Too much, because people tend to hate having to support extremely heterogeneous system. So usually when the system itself is going to run something that is going to be a large scale, usually the system itself is designed in such a way that we are trying to avoid doing things that are problematic and trying to use different pieces of hardware from different vendors and from different epochs or different ages, basically. So this is what we are trying to achieve. Now, what is happening in the background here is that all of these services are being downloaded as Dockers or some sort of a service. They're getting configured one by one, and then all the connections between those are getting configured. So everything that needs to be configured to explain to, for example, Horizon, where the compute service is, where the storage is, where the images are, where this networking is, and so on. What are the addresses of the servers? What are the addresses of the databases? Each service has its own native database, so the databases need to be configured. So this is what is happening in the background. It used to be that you had to more or less do this by hand. It can be done, but it's not a pretty thing. So let's wait for the thing to finish. I'm going to take a quick pause and wait for this thing to finish itself, and then we are going to be I'm going to be continuing showing you how the OpenStack actually works. Okay, so let's continue this thing. Now it's almost, let's say, 40 minutes later, and it's a good thing that we didn't wait. The installation itself is finished. As you can see here, it gives you all the information that you need. I always screenshot this thing so I can use it later. So it gives the address for the machine, it gives you the keystone, the identity address, it gives you the address to the dashboard, it gives you the address for the name of the default users, and it gives you the password for default users. So let's try to connect to this thing. Let's see if this is going to work. So let's say this is going to be 1.48 slash dashboard, and let's see what is going to happen. Hopefully we're going to see something. Admin demo, and let's make this thing go. Okay, fine, it works. So we have a running OpenStack. It gives me the idea that I have my projects here. Inside my project that I'm right now part of, I have the instances, I have the images. Everything is more or less empty. This is the demo image that is available for Cyrus, which is the smallest possible image that you can actually get. So 20 megabytes of disk space. I have my volumes, which is empty. I have my networking with topology that is basically public and shared. That's it, but it gives you some sort of a topology idea. I have a list of my routers, which is empty. I have a list of floating IPs, which is empty because I didn't configure anything. But I have a running configuration that I can then use and abuse. Also, what I can do is I can create and see system information. I can create different volumes. I can create different volume types. I can create different parts of the system. For example, I can create flavors. I should be having some flavors already assigned, so there are flavors here. I can create some instances and so on. But the idea of this video was not to create the to explain everything about OpenStack. It was just to install it. This is a good place to start. This can be done on any laptop. Just bear in mind that you are going to have to use a little bit of disk space. Let me see how much did this thing actually take. So let's see what it says at -h. So it used something around 17 gigs of disk space actually. It is going to check for disk space, so try to have at least 100 gigs available. It says in the manual that it requires 50, but I'm not going to believe this. I'm going to go with provided with more disk space. It doesn't have to be actual disk space, because you can also always over provision and basically lie to the system that you have enough disk space, because it is going to take as it took here. And as I said, this can be done on laptop. You can have your own system here. And the most important part is, once you have the things up and running, you can switch from the projects. You can create your own projects, and you can do the inside the administration. You can then go and change things, create. In the admin, you can actually create projects, create instances, create images, and so on and so on and so on. And the most important part is that you can use the API access, so you can create your own API endpoints. You can create your own credentials, and then you can actually connect to those API endpoints and try to do things using outside tools and using scripts. The main purpose of the OpenStack, or the dev stack that we have just installed, is to enable you to create your own development tool space. So instead of having to connect to a huge or at least big installation of OpenStack somewhere else, you can create your own, and you can test your tools in a small dedicated environment. And since this is a virtual machine, what I could actually do is I could shut it down right now, snapshot it, and then reuse it whenever I need it, to just get back to this point and just go back from the clean install of OpenStack. So I hope you enjoyed this part. I'll be seeing you next week, or in one of the next episodes, because I have some other things that I need to install, so I'm going to bring you up with me for the ride.